Therefore, since today is our very first day, we will be discussing about what is the structure of grade 11 syllabus, and we will also be discussing about the first lesson, which is about writing programs, and that is our first lesson. First of all, let me share my screen, and I think you have already looked into your book, so which is grade 11 book. In grade 11 book, basically you have in grade 11 book, let me open that. Let's go to the books, and this is grade 11 English medium book. And in this book, basically the first lesson is, it's about programming, and we have to learn algorithm and how to write programs. So actually, this will be easier one for you because you have already done, if you have already completed grade 6, 7, 8, 9 syllabus, will be very easier chapter to you because throughout those years you have learned programming, and this is nothing new in that case. Anyway, let me begin just by introducing how programs are developed, why programs are important, and how software programs are developed, right? So, you know, information is termed as the most information. Information is called the most valuable economic resource in the world. The most valuable economic resource. In Sinhala we call Vadat Vatinama Arthika Sampata. Why we call information as the most valuable economic resource? Because assume that now in this current pandemic situation, if you have a mechanism or if you have a method to heal COVID-19, or if you have a method to get rid of COVID-19 spreading, or stop or minimize any tested method or proven method to stop the disease or heal the disease, that is just information, but it will be really valuable. You will definitely become a billionaire without any doubt, because if you know a method, if you know a correct method which can be practically applied and generate results, that is just information, but it will be really valuable resource to entire world. So similar to that, think about the Microsoft recipe. So think about, so when you are buying a software, so let me ask a small question. When you are buying software, are you really buying the software, or are you buying the license to use software? මොකක්ද ගන්නෙ? When you are buying a software, are you really buying the software? Software එකද ගන්නෙ ඔයගොල්ලෝ? software එක පාවිච්චි කරන්න license එකද?
License.
It is license. Yeah, it is license. License means it is just information. No? License key is information. So assume that, okay, so Windows 10. Windows 10, if you check with the resources, okay, let me check with the resources. How many Windows 10 licensed sold in 2020? Let's ask how many Windows licensed sold in 2020. You can ask the question, and you can say Microsoft hit 1 billion Windows 10 devices in 1 billion Windows 10 devices in 2020. This news was published in 2019 September 14. Prediction was they will hit 1 billion Windows devices. Windows 10 license key, what is the price? So it depends. Let's say it's $100. Windows 10 license key is $100, genuine Windows 10, but version to version it's different. Home edition, professional edition, ultimate edition, they have different editions. Version to version it's different. So it's 1 billion. 1 billion into $100 is 100 billion USD. 100 billion USD means how many rupees? Just imagine how many rupees. So if you got a chance to hack Windows and get all these license keys, or how these license keys are created, the recipe of license key. කොහොමද මේ license key එක හදන්නේ? ඕ කොහොමද මේ license key එක valid වෙන්නේ? එහෙම නැත්නම් කෙලින්ම license keys ටික. ඒ ටික 1 billion hack කරොත් කවුරුහරි hack කරා නම් and එහෙම නැත්නම් ඒව අරගෙන hack කරන්නේ මොකක් හරි විදිහකට හොරෙන් අරගෙන දුන්නා නම්, so what will happen? That will affect entire US and its economy even. So that's what third world war is, right? Third world war is information war. They're fighting for information. They're trying to anyway, rather than damaging people, they are trying to damage information resources. So you can just access these links. I'll give you a wonderful link. You can just go and search this. There's a map called NORSE map. NORSE, NORSE map, or cyber attack maps. So then that is sometimes called digital attack map or NORSCOPE. So whatever, I'll show an image without showing because you can search this. So this shows, this NORSE map shows live attacks happening in the world. This is using sensors. I mean, routers වල තියෙනවා sensor එකක්. ඒ router වල තියෙන sensor එකෙන් තමයි මේ map එක ඒ වෙලාවට generate කරන්නේ. මේකෙන් පෙන්නනවා කවුද කාටද attack කරන්න කියලා. මේ missiles වලින් weapons වලින් නෙවෙයි. These attacks are done using information. Information යවලම information වලට attack කරනවා. So that is third world war. අපි හිතමු Microsoft ආයතනය එහෙම නැත්නම් let's think about Facebook or Microsoft. Let's think its service is stopped for 30 days. It will definitely affect economy of USA. So I think you're asking, yeah, it's real time. One student's asking whether it's real time. Yeah, it's real time. It's real time. Even though you know it's real time, you can't avoid that. Assume that someone is attacking you and you can see the attack. You can see the attack happening in real time. But can you unplug your server and shut down your server and move? That is not possible. Even though you know attack is there, but you can't take any action because you can't prevent that. No, anyway, you can't prevent that. Preventing mechanism is easiest. Preventing mechanism is disconnecting. You can disconnect your servers from internet. Then again, attacking purpose is also this. No, attack karannet me disconnect karanna connection එක නවත්තන්න, denial of service. No? To stop the service they are attacking. To stop the service they are attacking. Now you unplug your server and go. Then their intention is anyway successful. So no way to prevent that. You just search NORSE map Facebook attack. Facebook was down, I think 1 or 2 years ago, just 1 year ago, I think. Facebook was down for 20 minutes. So you can see the NORSE map footage or NORSE map, that time NORSE map view. It is there in here Daily Mail. They have updated the Daily Mail they have updated that NORSE map view of the particular attack. So you can see how many attackers are attacking the particular place same time. These are called botnets. Actually, I'm not going to discuss this much. Then this will be technical topic related to security. But I don't want to make that happen because this is not a hacking class or security class. I'm going to start my very first lesson in grade 11. So that is not related to hacking in any way. But what I want to highlight here is information is one of the most valuable economic resources. People are fighting, countries are fighting for information. Try to how they have revealed means you have asked the question saying how they have revealed. Revealed means at that time you can go to a NORSE map and see a footage. So this is live. Anyone can see. You can also go and see how this is happening. Anyone can see. They can backtrace. They can go rewind and see what has happened. But that is useless because you cannot find the exact person who has attacked you. That's the thing. This attack will be launched by one person, but they are using different other identities. Sometimes the attack might go from your computer, because your computer, we'll discuss this about when it comes to impact of cybersecurity on security things. Let's discuss at that time. Okay, first day itself we are going to discuss. This means it will be a techie or high tech topic for some kids. This is not high tech topic, but anyway, for some kids they will feel uncomfortable. So therefore, let's stop from here. I'll discuss this later, because anyway I'm also interested in the particular topic. So if I start talking, I will talk for hours, right? Anyway, I just wanted to highlight information is one of the most valuable economic resource. Not one of the most valuable economic resource. Actually, it's called the most valuable. You can call the most valuable. Obviously, it is valuable than gold and all. And to protect these information systems, therefore, we need strategic way to engineer software, and that is called SDLC. The reason for having SDLC, or system development life cycle, no other reason why you need a proper way to develop a system or proper way to develop software. Sometimes you call software development life cycle. Why? Because information, the value of information is really high. Software or programs deal with information. They eat information, they digest information, they output information. So they eat data, and then they digest something and they produce information, whatever. Anyway, they deal with information. Since software deals with information, it's really critical to, because you need some engineering approach to engineer software. So think about Excel. I think in grade 10 you have learned Excel. Excel can be used by management. Excel can be used by finance. Excel can be used by a person like you, student. Excel can be used by president or government to keep its data. So what will happen if this Excel is not reliable? Think that payroll or the pay sheets or employee payments are stored in Excel sheets. What will happen if Excel is unreliable, and if it is adding additional zeros to your payroll? The employees will be lucky, employer will be unlucky. Excel sheet එක දාලා තියෙනවා pay sheets හරි නැත්නම් pay කරන්න ඕන amount දාලා තියෙනවා. Automatically Excel වල වැරද්දක් හින්දා ඔය pay කරන්න ඕන amount එකේ අගට බිඳුවක් add වෙනවා. අපි හිතමු 80000ක් ගෙවන්න තියෙන salary එකේ අගට බිඳුවක් add වෙනවා 8යි. ඔය විදිහට හැමෝගෙම salary වල අගට එක බිඳුව ගානේ add වෙනවා error එකක් හින්දා Excel වල. Then employers, a company එකේ වැඩ කරන employees ලා lucky, හැබැයි employer unlucky වෙනවා ඒ වගේ වුණොත්. Sensitive information, we are dealing with sensitive information. Those are we are dealing with Word, MS Word, directors la වැඩ කරනවා, government එක වැඩ කරනවා MS Word එක. So everyone is working with MS Word. The way notification public වෙන්න ඔය එන ඔයගොල්ලන්ට එන මොනවාද, ඔයගොල්ලෝ news විදියට දකින්න සමහර letters Facebook එකේ share වෙනවා. Letters, how those are generated? Using computers, computer generated. What will happen if there's an error? Definitely it will affect people and their lives. So information is really critical. Therefore, it needs engineering approach to engineer software. So that is the requirement. So then let's move and explore this engineering approach. The first step of this is identifying the problem. You call problem definition. Identifying the problem. The second one we call requirement analysis. First, you have to identify the problem. Second, you have to identify the requirement. Problem and requirement, two things. Okay, problem is you are hungry. Requirement is you need food. Okay, sometimes problem is you don't have food in your house. Requirement, you need to travel to find food. ගෙදර කෑම නැහැ කියන එක තමයි ප්‍රොබ්ලම් එක. ඒතකොට රික්වයර්මන්ට් එක අවශ්‍යතාවය මොකද්ද? ගෙදරින් එළියට යෑම. ඇයි එළියට යන්නේ? කෑම හොයන්න. So the problem එක requirement එක කියන්නේ දෙකක්. Problem is what is the actual issue. Problem is adding two numbers. Requirement, you need two numbers and addition operator to add that number. Problem is finding out circumference of a circle. Requirement, you need inputs, the radius of the circle as well as the value of pi. Then if you have pi and the variables or radius, then you can find out circumference. Find out area of a circle. Again, you need radius and pi. Those are the requirements. So circumference is the problem. Finding the circumference is the problem. Requirements are something else. Requirements are basically inputs, outputs, and processes required to solve that problem. Inputs, output, processes, decisions required to solve that problem. Right? That is requirement. In requirements, you identify those things. There's an additional step in requirement analysis that is called feasibility study. That means you have set of alternatives, set of alternative ways to do that. So for an example, adding two numbers. So what are the alternative ways? Adding two numbers, you can do like this. First number, you can get the first number, store first number, add the second number. That is one thing. Take the first number, store it, add the second number. That is one thing. The second step, you put addition and then you feed 3 and 4. This is called prefix notation. You put addition, then what to add? 3 and 4. You can put like that. Or you can store 3 somewhere and store 4 somewhere, and you can store x somewhere, and you can then say x equal this 3 plus 4. Likewise, there are different alternative ways to solve a problem. So assume that you want to mark attendance. You want to mark attendance in a system. So you can employ an robot. Robot කෙනෙක්ව දාන්න පුළුවන් attendance mark කරන්න. That is one case. You can employ a barcode system, or you can put a fingerprint system. එහෙම නැත්නම් ඔයගලන්ට පුළුවන් අර පොතක් දාන්න. එනකොට අස්සම් කරලා එහෙම පොතක් දාන්න පුළුවන්. එහෙම නැත්නම් you can put like register. ඔයගලන් ඉස්කෝලේ තියෙන එක බින්දුව දාන register. එහෙම එකක් දාන්න පුළුවන්. There are different solutions, different requirements, but you have to find the most feasible one. So if you are in a bank, you can't mark ones and zeros like in your register. බැංකුවක නම් ඔයා වැඩ කරන්නේ බැංකුවේ ආවද නැද්ද කියලා බලන්න මැනේජර් ඇවිල්ලා එක බින්දුව මාක් කරන්නේ නැහැ. හැබැයි ඉස්කෝලේ පුළුවන්. Because you have to think about social feasibility in the bank. You can't call name and mark. That is not socially feasible. That is not environmentally feasible. You have to think about some other system, maybe fingerprint or some other system. In a classroom, you can use a barcode. In a school, you can use a barcode or register. Right. In exam, to mark attendance, you have some documents, confidential documents passing. Right. That's how you mark attendance in the examination. No barcodes, no fingerprints, nothing like that in A-level examination, O-level examination. You have different documents came from or printed by the government and sent to the school based on the school requirement, and that document you have to mark. Likewise, there are different factors you have to consider. You have to think whether the solution is environmentally feasible, solution is socially feasible, legally feasible, then economically feasible. Likewise, you have to think about feasibility of the solution. Then after finding out the most feasible solution, you have to design. You call system design. That is what we are going to learn today. System design. System design phase, you do the planning. In system designing place, you do the planning. Right. Then you have actual system implementation. We call system development. That is called actual system implementation or the programming, coding. For an example, even though you draw a plan or you draw a plan of your house, you can't live in a plan. No. ගෙදරක plan එකක් හදලා plan එකේ පදිංචි වෙන්න බෑනේ. You have to actually construct the house. That comes here. System development, actual construction. Then you have system testing. Whatever constructed or whatever built or whatever engineered need to be tested. You have to test unit by unit, that is called unit testing. You have to combine units and test, that is called integrated testing. Testing unit by unit is called unit testing. Test by integrating is called integrated testing. Entire system can be tested, that is called system testing. Entire system can be tested, that is called system testing. Okay, then at the deployment, in the deployment phase, deployment means handover. In deployment phase, right? You can, before deploy, you have to test with your users. That is called user acceptance testing. Before this deploy, you have to test it, users, whether they like it, whether they can use it. Likewise, you have to test. It is called user acceptance testing. And finally, you have R&M, which is called review and maintenance. Review and maintenance, that is very important, because once deploy, you cannot just move away. You have to look after the system by providing updates, patches, updates. You have to look after the system. After getting Windows deployment, that means after installing Windows 10, time to time they are reviewing, they are asking to send error reports, they are sending patches, updates. That is called review and maintenance. So this has happened to Windows 3.1. The problem was GUI. They have developed graphical user interface operating system. Requirement is to put into the computers. Then they designed and developed Windows 3.1, tested and given to users, maintained. But later they feel that Windows 3.1 is not secure. It is not user friendly. The new problem is finding secure and user friendly OS than Windows 3.1. Then they started researching about that, analyzed the problem, and found that Windows 95 is the solution. Then developed, tested, and given to users. After some time, they feel that Windows 95 is not going to work out. It has limitations of its display, graphics, and all, and again security and some other aspects. Need to improve the usability. They came up with 98. Story is not yet end. After that, they came with Windows XP. Before that, Windows Millennium, Windows Me, Windows XP, Windows Vista, Windows 7, Windows 8, now Windows 10. But it's not going to be end. They will, I don't know, counting system of Bill Gates, because he's not counting like 1, 2, 3. Yeah, 1, 2, 3 කියලා ගණන් කරන්නේ නැහැ නේ. Windows 1, Windows 2 එහෙම නෙමෙයි එන්නේ. ඒ හින්දා මම දන්නේ නැහැ ඊළඟ එක මොනවා වේද කියලා. Can be Windows 11 or can be Windows 2021 or Windows COVID version, whatever. So they will release a new version after some time, because after review and maintenance, they will feel that it is also boring. Let's come up with new solution which is supporting IoT and new devices. So they will introduce new operating system. So that's how it's going. Starting from Apple 1 to current Apple version, how they came, or starting from Android, some version or Lollipop or whatever, how they have come and introduced the new Android OS. Or starting from some old kind of Symbian, how Nokia came up with new operating systems, and likewise, all these things are results of system development lifecycle or software development lifecycle. Hopefully that is clear. Why it is a cyclic process? Because you have to repeat again and again. So today we are going to learn 2 things. So basically, how to identify a problem. So anyway, no need to identify a problem, because problem will be given in the paper as a question. Problem එක paper එකේම දෙනවා. එහෙනම් වෙනම define කරන්න ඕනේ. You have to identify the requirement. Okay. So I'm going to add 3 numbers and print total and average. Add 3 numbers and going to print total and average. Can you tell me what are the inputs? What are the inputs? Can anyone? Add 3 numbers and print the total and average. Do we need inputs or no need of inputs? Inputs ඕනද නැද්ද? Numbers 3ක් එකතු කරන්න inputs ඕනද? What are the inputs? Hello? Are you there? Can anyone talk?
Yes.
Yeah, Chandala, tell me. Yes. Do we need inputs? What are the inputs? To add three numbers, you need simply number 1, number 2, and number 3. You need numbers, no? Otherwise, how to add numbers? And what is the process? Process is adding numbers. Is the process. What is the output?
Addition.
Yeah. What is the output? Output is, yes. Output is the answer, or maybe total and average. Those are the outputs. You have inputs, numbers, adding numbers, and finding the total. Not only that, adding numbers and finding the average. Those are the processes, and outputs will be total and average. So this is in requirement analysis space. Let's go to your book. Right here, they have given a problem of making, preparing a letter to be posted. Problem is given, preparing the letter which can be posted. Inputs: a sheet of paper, pen, envelope, stamp, glue. Those are the inputs. Write in letter, fold in, paste in envelope, write in recipient address, stick in the stamp. Those are the processes. Output: the letter to be posted. Okay, they have given some another example. Making a cup of tea. Tea leaves, sugar, hot water. Those are the inputs. If you are making a tea, maybe milk also needed, required. But for plain tea, you need just tea leaves, sugar, and hot water. And also some mug and all. Mug, those things are also needed additionally. Putting tea leaves into the strainer. So strainer also input here. So it is not given, but strainer also required. Pouring water to the cup. Cup is also input. It is also not recognized by the system engineer, analyzer. But anyway, cup, strainer, those are also inputs. Adding some sugar to the cup, strain, spoon. Spoon is also input. Right? Spoon is also input. So likewise, yeah, that is recognized. Likewise, so each and every noun will come as input here. So it is too dangerous now. So test in the taste, taking smell of from the cup. If taste is not satisfactory, go to step 3 and repeat the step. So if this is not satisfactory, you can add some more sugar and taste. But anyway, you can't undo if too much sugar. Then what you have to do is then you have to go to step number 1 and put some more tea leaves and hot water. Likewise, this is not complete example. You can't tell that this as a perfect example, because person to person it might be different. Anyway, you write some general steps. That is the only thing. So no one can write a perfect software, but generally you can address the problem. So that's what we are going to learn from this example. That is not error of National Institute of Education or any people who develop this material. That is not error of them. No one can develop a perfect one. Even though I think that I can do a perfect one and I am going to write this again, but that is also not perfect. Someone can come and tell, this is not required. This is too much. Likewise, someone can comment that. Similar to that, we have to address the general need. Okay, then there are some more examples. Let's try to. Okay, so before we begin, then we have to. So this part, I think it's easy. Requirement analysis is easy. You have to find out input, processes, outputs, and decisions. So that's what requirement analysis is. In system designing, you have to plan. In system designing, you have to plan. For planning, you need some tools. System designing, it has some tools. So what are the tools? Example, flowcharts. Flowcharts can be used to design systems. Then pseudocode. Pseudocodes can also be used to design a system. Flowchart, pseudocodes. So those are the tools. Not only that, you have some other things, structure charts, and then object-oriented diagrams, class diagrams, sequence diagram, like data flow diagrams. In advanced level, you will learn more advanced things. Anyway, designing needs some tools. In ordinary level, we are going to learn about flowcharts and pseudocodes. Right. Let's explore more about flowcharts. In flowcharts, you have some small set of symbols to represent different requirements and different processes, outputs, as well as decisions. So these are the symbols in flowcharts. Okay. These are the symbols that we are going to use. This is a diagrammatic tool. This is diagramming tool which is used to show the system designing. The symbol number 1 is rounded rectangle, or you can use an ellipse. You can use an ellipse. That denotes start and end. Start or end. This is input or output, process, decision, data flow, and connector. Okay. So just no need to by heart this. කටපාඩම් කරගන්න ඕනේ. මතක තියාගන්න lazy. Ellipse එකකින් start එක. Then input output එකක් නම් parallelogram එකක් තියෙන සමාන්තරාශ්‍රය. Input output is used to represented using parallelogram. Then process is displayed using square, rectangle, and decision is shown using diamond, and direction, data flow is shown using arrows. And then you have connector to connect multiple parts, that is circle. Those are the symbols. Very easy. Those are the symbols. Okay. So let me introduce small tool to do this. Let me introduce small tool to do this. Please go and access that. So if you, I think you can do it using your mobile phone. Then otherwise this is like a theoretical lesson, you feel boring. I'll give small kind of 2-minute, 3-minute break till I save this video and join back. You can do this. I'll show the URL. So you can use this one. This is called creately.com. Creately.com, and in creately.com you can use flowcharts. How we are going to Google it? Google like creately flowcharts. Creately flowchart. Then you will get this flowchart link. Creately flowchart link. Then click start drawing now, right? Then click start drawing now. Try to follow these steps, same steps. Search creately.com flowchart, right? Then click start drawing now. And then you will be asked to sign in. So no need to create account. You can use existing Google account and sign into the Creately. Try to access that first, Creately flowchart, then bookmark it, because later also we are going to use same thing to create flowcharts. Okay, one question, right? Okay, no questions. Right, I'll stop this and save the recording and come back to you, because why I'm saving the recording, because that is useful to you. You can later refer the video and repeat it, and it is easy way to remember things. Let me stop and come back. Same invitation, yeah, you can use the same invitation to log in back. Just give me 3 minutes, 3 or 4 minutes, okay?
Okay, sir.